Thank you, Dave. All right. First off, this is Liz's talk. Ian and I are delivering it for you. Ian knows the infrastructure. Ian, say hello.
Hey, hello there.
And yeah, he knows the Honeycomb platform and products. I'm a fairly new principal developer advocate at Honeycomb, but I'm not new to YOW. So I'm happy to get the opportunity to present to you today as a surprise. And today we're talking about how Honeycomb has used and is using limited engineering resources to make the most of our engineering resources. Honeycomb as a company is about 5 years old. It's a fast growing startup, but it is a startup. And so we're very careful with the resources that we have. Honeycomb is observability. And as observability, this is a space that's evolving rapidly. It's all about helping developers understand their code as it works in production. Observability means like being able to understand what's going on inside the system without having to dig around in a production REPL, but instead using signals that it sends out to us. This space is growing. And so there's a lot of competition, and there's also a lot of increasing scale. So at Honeycomb, we need both velocity and reliability. This is not a trade-off. I mean, in the past, people have considered this a trade-off, but it isn't. It doesn't need to be for our customers, and it doesn't have to be for us. So this is what we've done to get both. First of all, Honeycomb has about 24 engineers on our entire product and platform. And now a year ago, this was 12. So this is not a lot of people building a really impressive piece of software, a product that we also operate for our customers. And we want our system and your systems to be humane to run, meaning they don't make their developers miserable. They don't keep their developers up at night wondering if they're going to get paged and wondering whether the features we've added are even doing anything. We want it to be easy to know when things are wrong and also to figure out what's going wrong. We do this by ingesting telemetry. Okay, so telemetry is signals that your system sends out to say how it's doing. This can be metrics, but it can also be traces. Those are a little better. One way or the other, it's events that said, hey, I got a request. It was from user ID so-and-so, and they sent it from this region in this browser. And then and by the way, then I did this database query and it took this long. And all the important activities that our system is doing, it can tell us about with telemetry. And Honeycomb slurps that all in, and then it lets you see what's going on, both as a series of graphs and as accessing the raw data. So you get like the benefits of metrics and the benefits of logs, except combined and prettier. The idea is that you can ask questions of your data like, how many requests came in and how long did they take? And then you can be like, I want to know more. Okay, what was up with these slow ones? What customers were those for? What is going on in this data set? And you can be like, well, did the query take a long time? Maybe, or does it vary by region? You can break it down anyway, and then get to a single piece of data and a request and see the story that it tells. And this is another requirement that we have. We deploy on Fridays. We deploy regularly. At Honeycomb, we don't want customers to be afraid of deploys, and we don't want to be afraid of deploying. We want to be able to sleep easy, even on weekends. For instance, here's a graph of like how many deploys happened a chunk of last year. This graph shows a count of the number of different production versions that ran in production each day. And on a weekday, including Friday, and it's about like 12 to 14 different versions ran in production. So we had 11 to 13 deploys that day. And this is our continuous delivery. Now, continuous delivery doesn't just happen. It's hard. It's an investment, because in the end, if you want your software to run smoothly, you have to build like software around the software and software around that. So like you've got your tests and you've got your version control, and then you've got your deploy system. And it's an investment in some of its infrastructure, some of its continuous integration and delivery. It's a lot of tooling. It's a lot of tooling to make the focus of our interest, our production software, be able to change smoothly and stay reliable. This talks tells you some of the stories of how we got there. It is an investment in tooling, and it has paid off, partly because it's not just any tooling. We didn't like invest in all the tooling. No, we don't want all of the alphabet soup of every developer tool that is currently sponsoring this and every other conference. We have to be selective, both because there's a cost in implementing something, and there's a cost in like cognitive load of using and understanding everything. So we needed to be thoughtful and choose, okay, what do we need? What can we get from a vendor that we can rely on? What is available open source? And then there's those very few things that we wind up developing on our own that are greenfield, but you don't want too many of those, because you build it, man, take care of it for life. Code is like children that don't go to college. So in the end, it's not all about code either. It's the people that matter, because every resilient software system is a socio-technical system that includes the code that runs and the people that watch over it and change the code that runs. Our code learns from us because we change it, and we learn from our code, especially when we have observability. So we have to care about the code and the people together. And that means that we're continuously looking for misery and not tolerating it. There's always going to be technical debt, stuff that we wish we did differently, stuff that we wish we hadn't done at all. But what among this matters now, maybe more than it did? I mean, what investments need to be, what small investments need to be revisited again and redone, both in the product and in our tooling? Because we need to improve where it matters. And that starts with like finding out what matters. Because finding out what matters, because what we get out of this continuous delivery is we can speed up product development and keep our infrastructure safe. So we've got our reliable infrastructure that's supporting our evolving product. We want to embrace risk. This isn't about don't change anything. It isn't about don't ever be wrong. It's about make being wrong cost less. And then we must never stop improving. I mean, it's not about getting anything right the first time. It's about coming back when we need to. What do we need to support the next improvement in the product, the next level of scale, the next level of smoothness in our process, the next generation of engineers that are joining our company? We have to keep going. So first, here's how we keep going on product features. Here's our recipe. Step one, instrument. And by instrument, I mean add code that emits telemetry that will then go to Honeycomb, of course, and then we'll be able to see whether it's working in production. So we call this observability-driven development. What it means is before or during, as part of writing the code, I ask myself, how will I know this is working in production? Because when it's in production, I want to be able to see a difference. I mean, yes, I could like go to the website and look at it and see a difference the same way a customer would, but also I as a developer, need to see a difference. And that comes back to me through telemetry. So if I'm adding a new piece of data that's going to be a new database query, I'm going to be sure to put that in there. Hey, they asked for this thing, so we retrieved this and it took this long. Or maybe it's a new page in the product, and I'll make sure it emits something when people visit it and also when people actually use it, so that I can know not only is it not broken, but are people getting value from it? Is it behaving and producing the effect on the world that we hoped? All right. So I think about that as I'm coding, and I put that in. And then, of course, there's tests also. Does the code work? Functional tests. And does it look right? Because when you're changing the UI, I mean, especially if you've got like a lot of code reuse going on, it's hard to know what all you're going to affect. We have storybook tests for that, where we have a kind of golden master of what does the DOM look like. And so if you change a component, it'll like re-render all the other components and tell you if something changed. This gives us confidence that that is safe to deploy and won't even look weird. And there's a balance. These tests are sometimes a lot of work because you do need to update it when you did change something intentionally. But our goal is that if the tests are green, it's gonna work in prod. And then we also put our code inside feature flag checks. The goal is that a deployment has nothing to do with a release of a feature. Well, not nothing, it's definitely a prerequisite, but as far as a customer is concerned, deploying generally does not change the code. Flipping a feature, or I'm sorry, deploying does not change the product. Obviously, change the code. Okay, deploying does not change the product. Turning on a feature flag changes the product. That changes people's experience of a product, which is beautiful because then we can choose whose experience gets changed. So we can flip feature flags differently per environment. We can be like, okay, only people on the internal plan can see this feature. And we can change the behavior of the application according to who's using it. That gives us like a lot of buffer between a deploy and a change that's going to impact how the site looks, how it performs. This gives us a lot of control. And then, of course, we have continuous integration, meaning our code is always being combined with everyone else's code, and we're checking that it still works, including the tests. And here is, we use Circle CI for continuous integration and deployment, mostly integration. Anyway, it gives us a cool little picture of the build process, and you can see all the steps and how they line up and run in parallel. But you can't tell how long it takes. So for instance, if we want to improve our build times and we want to make sure we put our effort where it matters, then it helps to have traces. We are using Honeycomb here to diagnose Honeycomb builds. And so this purple thing here at the top is the whole trace of the build. And then there's these little steps, and some of them are fast. And this one, for instance, is pretty decent. That's the testing of the Go code, the Go test. And then that one's like almost entirely actually running the tests. But then there's the JavaScript dependencies. Wah, big orange bar. And then the JavaScript tests are down here being fast. Our tests are fine. Our tests are totally fast enough. But oh my gosh, NPM. This gives us the evidence that we need to know that if we put some effort into getting Circle to cache those dependencies, which it can do, but it's not trivial, then that effort is going to pay off in shorter build times. And shorter build times totally matter. They matter because as a developer, you've got this stuff in your head, and you've only got it in your head for so long, this code change that you made. So that automated integration needs to be fast, like faster than our attention span. And then, I mean, the build is green, great. That's as much as the computer can do, but also we need a human. A human looks at every pull request. There's not a question of, is this important enough or big enough or dangerous enough to get a human to look at it? We always get a human to look at it. And this isn't expensive if you keep your changes small. And that's going to be a theme. Keeping the changes small makes all of this easier. And also making all of this easier keeps the changes small. Okay, so we get a human pull request review, and that combines with the robots of our tooling and our deploy system to make a nice little human robot socio-technical high five here. And this gives us some confidence that it's time to push that green merge button. And once we push that merge button, it's going out in the next deploy. Now, we don't deploy every change separately. We deploy once an hour. But still, once you merge it, it's going out. So we have automatic updates to deployments, rollbacks and pins, which we'll mention later to help with mitigating the cost of failure. And then we're not done yet, because you're not done when your software is in prod. As a product developer, it is very important for me to understand what's going on in production. My responsibility does not end at delivery. And remember way back at the beginning when I did like the instrument your code, step 1 as part of development? This is the part where once it's in production, I can check whether the code is executing at all. Maybe I'll turn the feature flags on as necessary and for myself or for the environments I want to see. And then I can look at what's happening. And we look at it right away to see if, did we bring something down? And we look at it later to be like, okay, how are actual people actually using this? Is this having the impact on the world that I hoped for? So in production, in like Honeycomb production, customers observe their data, but then we need to observe them observing their data, right? So that I know whether my change to Honeycomb made a difference. So we've got like a whole nother instance, another environment of Honeycomb called dog food, because we eat our own dog food. Also, we have a dog theme, it's fine. We eat our own dog food by using Honeycomb to evaluate Honeycomb. And I mean, and also sometimes we'll turn feature flags on in dog food and test some stuff there. It's running the same code as prod. We don't run different code. This is not a staging environment. This is another production environment that we can separately tweak feature flags on. But of course, I mean, if we're going to tweak feature flags and we're going to observe stuff in dog food, then we need to observe ourselves observing stuff in dog food. So we also have kibble. This is fine. So there's 3 environments where we can have different feature flags, but they all run the same code. And here, for instance, if I've deployed a new SLO adoption page, I can go look at whether that's really being hit in production. How are the response times? Are people interested? Right, and that's how we use Honeycomb to test Honeycomb. And that's how we have 24, it's probably a little more than that now, engineers deploying at least 12 times a day. And this is DevOps. And when you think about DevOps, you might think about the DevOps research and assessment data, DORA, which is also expressed in Dr. Nicole Forsgren et al.'s book, Accelerate, about how there are certain DevOpsy metrics that correlate with high productivity teams. Like being able to deploy quickly, it turns out is strongly correlated with delivering business value really well. And the fun thing about these metrics is that they're not independent, they all feed each other. So any one that you can improve all the others. What we've talked about with our continuous deployment is about reducing lead time. Lead time from, okay, I think this change is done, to, well, it's in production and I'm checking it out. The shorter that lead time, the more high performing your team is. And in our case, we've got it down to about 3 hours. So, I mean, once you make that commit and you think your feature's done, you've got to wait for the build and also a human to review it, try to keep it short, and then you can get a review in an hour or so. And then it takes an hour. You've got to like wait for the next push and deploy to come up. So about 3 hours. I mean, okay, that's longer than my attention span, but it's less than a day. I can check back in. It's fine. We only have this that code change loaded up for so long, and if I have to like wait days or weeks to see that change in production, I mean, why would I even go look at it? I've forgotten it. I'm on the next thing by now. So when it's important to us that engineers care about how their code is working in production, then we got to make it easy for them to remember what they just did and in time to check it in production. Okay, when you do that, when you reduce the lead time, it's easy to increase the deploy frequency. Shorter deploys, do more deploys. When you do more deploys, you have fewer changes per deploy. And that's really important because the fewer changes you have in a deploy, the lower the risk. And that means your failure rate of deploys goes down. Also, we're using feature flags, so you can flip one of those on at a time, and that makes it even fewer changes at a time. So we get this increased confidence, and that increased confidence helps us reduce the lead time by generally letting people not introduce more blockers because they're freaked out about the risk. So this all feeds back on itself, and it lets us do deploys more frequently because we're more comfortable with it. And then also, again, because we have fewer changes, the time to restore goes down because we know what changes, and we have the feature flags, and we can do a rollback, or we can do, if we need to, like revert the commit and push forward a code fix that might take 20 minutes. But we lower our time to restore. And again, that goes back to less fear going into the deploy so we can do more of them. And this is high productivity product engineering. This is a great feedback loop. It's my favorite DevOps feedback loop. But there's more to product. The product wouldn't work without infrastructure. Now I'm going to hand it over to Ian, who knows all about this.
Hi, I'm Ian. I'm on the platform team here at Honeycomb. Boop, please. So infrastructure is what leads us to product, right? We don't have a running product without the infrastructure underneath it. And so in terms of building that infrastructure, our main goal has to be, can we keep the product both running, but also delivering to support the business? Slide. And Kubernetes is not the goal. Slide. Reliability and simplicity are the goals. And I'm going to pause for a minute here. Can you go back a slide, please? This used to be where we say Kubernetes is not the goal. We're not using Kubernetes. We've got simpler tooling. And one of the things that you'll notice as a theme in the next bit of this talk is we're comfortable with revisiting that. So as it turns out, we're in the process right now of migrating over to Kubernetes. We're in the later stages of that project. But it's still true that Kubernetes is not our goal. Simplicity and reliability are our goal. So let's talk about how we ended up here. Slide, please. Everyone starts somewhere, and you know, every team has their warts and the ugliness in their code and their process that don't quite work. So what's critical though is coming up with concrete steps that you can take to move forward from there. Slide. And you start with automating the painful bits. Our old Infra did this too, right? This is not a realization that we came to just last week. We said there's processes in making our code be delivered to production, and those should not be human, they should be automated. We don't want humans to be doing the boring, repetitive toil. Slide, please. And so that means fix the duct tape. What are the places where you are sort of walling that off and not looking at it, and what can you do to make those better? So we've had our fair share of duct tape and worked on it incrementally over time. I mentioned we're moving to Kubernetes, and that's kind of a big bang migration. Yeah, it is a big lift. But along the way, we're saying, okay, what are the components of our existing infrastructure that have not worked so well for us that are causing pain? And what can we do to either fix those for now or fix them permanently? Slide, please. We value having reproducible environments. So we don't have any infrastructure changes that are human operated, that, oh, right, somebody needs to remember that here's that thing you do manually in dog food that doesn't apply to production, and vice versa. We don't have custom config anywhere. And having that centralization, having that version controlled state of our infrastructure is a key piece of making it resilient. We had that before, and we're continuing to maintain that with Kubernetes. Slide, please. So here's where we, in the history of talks like this one, we said raw VMs are much simpler than containers. I don't want to have to think about Docker. I don't want to have to think about C groups. I just want to throw my stuff on a VM and away it's running. And it turns out that served us well for the last 5 years, right? We made it from little dinky seed stage startup up to where we are today. And we're pretty happy with that. But we've come back to revisit this decision and say, okay, as our infrastructure grows, as the number and complexity of services we operate grow, as the size of our team grows, maybe doing that maintenance is not the right thing for us. And so we've been looking at putting things into containers and saying, oh, it turns out for these specific things that we're doing here, we think that containers abstract away a lot of that work. Slide, please. So originally what we had was, we code booted Chef on a VM in AWS. We ran Chef on it, and that deployed a whole bunch of scripts and tooling. And then we used cron to rerun that Chef on our hourly deploy, and that would do a deploy for us. And that turns out to be very simple at one stage of development. That turns out to be very simple when you have a small number of services. And unfortunately, as we grew, we came up with more and more places where, oh yeah, this one's a little bit different and that one's a little bit different. Slide, please. But the thing we're not changing here is this principle of repeatable infrastructure that's all in code. So we're still not making changes that are, oh yes, somebody goes and runs a command by hand. Somebody goes and logs into a service and makes a change to it, and that sticks around. We're again back in this world of green button means I push it, it merges, and something else carries it out to the next environment. Slide, please. So we centralize our state and we centralize locking. I don't have to be concerned that somebody else on my team or another team is making a conflicting change, because we have this going through some sort of central state management mechanism. And in an earlier rendition of this talk, we talked about using Terraform this way. So we were big fans of using Terraform Cloud, and the advantage of this, of course, being I'm not concerned that I and another engineer are both trying to run Terraform and ended up in a bad state. We're still using Terraform. That is how we deploy our Kubernetes infrastructure. We're also doing this now with, instead of our centralized state store that lives in S3 and runs a cron job and pushes to deploy that way, we're now letting Kubernetes do that work for us. So again, you'll notice we're not making a huge jump in the principles that we believe in of having this go through one blessed path, but we are making changes in these specific ways that we implement those goals. This also means that our infrastructure gets diffed and released in the browser. So I want to make a change to our infrastructure, whether that's in Terraform code, whether that's in Kubernetes code. I'm going to do that through opening a PR, watching what happens in a dry run in that PR, getting another human being to look at that PR, and merging that in GitHub. So you'll notice that we've taken some of these same ideas that we use in application development and are applying them in our infrastructure. There's really, again, there's there's not so much of this human process of what am I doing manually to get this service out into production. Slide, please. I think we are skipping this one, actually. Right. So all of our config, whether it's Amazon infrastructure managed by Terraform or application infrastructure managed by Kubernetes, goes through the main branch of our Git repo. And so we're not worried about, what is the difference between what's living in the repo and what's live in the wild. We're not worrying about what's the drift between these two things or between one environment and another. It's all codified in Git. Boop. And so here's the Terraform Cloud UI that we look at. We push a change to GitHub, and we can see that go out into Terraform. Down at the bottom of the screen there, you can see a planned run that has not yet applied, right? It either got planned and discarded or planned and hasn't yet been approved for merge. And further up from that, you can see a couple of failures. You can see a couple of green applies when things merge cleanly and applied cleanly. And again, we really have one place to look to find out what is the current state of the world that I'm responsible. What is the current health of my system in a way that makes it easy for not just me to know what I'm doing, but for my teammates to know what I'm doing, for on-call to know what's going on right now in the system that they're running. Slide, please.
Okay, thank you. All right, now I have a quick story about what happens when it goes wrong. And remember, we want the consequences of wrong to not be terrible. Well, we want that. All right, so here's a graph from, I think, July of 2019. And I mean, there's something weird there. What's that big spike downward? Let's zoom in on that. Oh, look. Something here is going from about 2 million down to 0 for almost 10 minutes. Is that bad? Well, I don't know. Depends what it is. Depends how you define bad. How broken is too broken? Well, at Honeycomb, we define that using service level objectives. So service level objectives are how we define success, and define success in a way that we can talk about it with business and product people and developers also. Because there is no such thing as a perfectly reliable service. That's not a thing. There are risks. We embrace that. And we kind of want to put a cap on it if we can. So in order to create a service level objective, I'll start with, okay, how many events did we see? How many things came in? In the graph, there were about 2 million things coming in, 2 million opportunities to succeed. And then we're like, all right, now let's define success. So maybe it's like, okay, we got a web request in, and success is HTTP 200 in less than 100 milliseconds. So what do we need to do and how quickly? What qualifies as success? And then we're like, okay, how many of those opportunities do we need to succeed at? And we can come up with a percentage and like a window. So let's say, maybe it's 99% over 30 days. That gives us an error budget of how many times it's acceptable to fail. So there is some level of allowed unavailability. And then that error budget can tell us when it's time to alert. Like, okay, if our error budget is, I don't know, 1 million requests that fail in a month, then, and we get an increasing error rate, well, are we going to spend our error budget at this increased error rate? Are we going to spend our error budget in the next 2 hours? We better wake someone up. Are we going to spend our error budget in the next 2 days? We should ping them in Slack. So there's levels of alerting, because you can say how bad is too bad with an SLO. So our SLOs are different depending on the parts of the product. For incoming data, we want to store all of it. So we've got a 4 nines SLO on incoming telemetry. We need to store it. Whereas like if it's queries, well, there's a human doing this. When they start up the default dashboard, we know what that is, and we're going to make it load in under a second, 3 nines of the time. On the other hand, like arbitrary queries that users put in, some of those are going to get hard. We want all of them to come back in, well, 10 seconds is pretty long, but we want at least 99% of them to come back in under 10 seconds. But there can be some ones that are longer. So those are 3 SLOs that we have at Honeycomb. Which one applies to this? Unfortunately, this was incoming data. This is our ingest. And that 10 minutes represents 10 minutes where we accepted Zippo incoming data. We dropped it all on the floor. That gap is in everybody's graphs for the next 60 days. Not good, not good. That was the 4 nines, 99.9% error budget. And we rolled it back, but 10 minutes, that's human speed of rollback. So we talked to our customers and we realized, okay, 10 minutes is about 70 days worth of error budget. So yeah, 3 months, gone. All right, we've burned our risk budget for the next 3 months. Suddenly, every risk is scary. So we halted deploys. And here's the thing, we didn't just halt deploys, we halted feature development. Don't work on that. Look at how this happened. What can we learn from it? And let's work on that. Well, it turns out that somebody checked in code that didn't build. So we didn't fire them. We're like, oh crap, the system should never take your code that didn't build and tell you it did. But no, there was some experimental CI config that made it show green even when the tests failed. When it couldn't even build the code. In fact, it still showed green. And then you'd think, well, but then there's nothing to deploy. But no, script didn't care. Script was like, oh, you got an empty file for me? I'll put that in production. Oops, I think we should change that. And then you think that, like, well, that the health check would fail and it would automatically roll back, right? But we didn't have that yet. Can't have everything at once. Whew. So it's time to apply some duct tape and replace some duct tape with stronger stuff. So yeah, we stopped feature development, prioritized stability until we could fix this problem, not just in one way, but in at least 4 different ways, all so that we as humans developing on the system, we can make better decisions because our tooling is telling us the right stuff. And we can automate the rollback for this case that a computer can help with. So we mitigated the risks and then got back to building. All of this is so that we can continue making Honeycomb ever more reliable and scalable. We can launch new services easily, especially with the new Kubernetes infrastructure. Burn less money because we can experiment with AWS as we need to. And most importantly, sleep easily at night because we know it'll wake us up if it's urgent and not if it isn't. You can do this step by step. It's never easy, but remember that every little improvement makes every other improvement easier. Everything we can do to make it easier to figure out what's going on in our system makes every deploy less scary, means we can do more deploys, means deploys gets less scary, and so on. We can improve the system. For more stories, you can read our blog. It's pretty cool. And that's it. Thank you.
Fantastic. Thank you so much. Virtual applause all around. And now, question and answer time. So everybody out there on the platform, jump into the Q&A tab, fire up your questions. Oh, look, the first question's from me. People vote for my questions. It's not just me, I'm just saying. Okay, so with relatively few developers and also the need to do PRs, how do you balance getting things reviewed with the actual coding and still get all the deploys done so fast, assuming you're avoiding context switching nightmares?
I'm going to let Ian answer this one. He's been on Honeycomb engineering for a long time.
Absolutely. Just about a year, actually. I have not been around since the beginning. I think there's 2 things that are an answer to this question. The one is reviewing code is part of my job, right? My job is not just to write code myself. My job is to make sure that my team delivers code. And so part of that is making sure that my colleagues are able to ship code. And in turn, they are making sure that I can ship code. And part of that is that's this process of a team that is mutually supportive, right? And so part of making that happen is carving out time in my day and saying, where do I want to make this happen? And sometimes that's going to be, oh yeah, I come in the morning and there's 3 or 4 PRs that have been pushed my way. Or it might be, it's 3 p.m. and a colleague says, I'm trying to get this shipped, before whatever happens and I have to leave for the day. Sure, I might turn that around faster, but it's very much about that mindset of this is not a distraction from my job. This is in fact exactly what my job is, to keep Honeycomb running smoothly. The other is this theme of smaller and smaller deploys, right? We've seen as an industry that the more often you deploy, the smaller your deploy is, the easier it is to know when a bad deploy goes out, right? Oh, what happened here, right? I don't have to take apart 4, 5, 10 commits to find out what went wrong. It's like, oh yeah, that thing went out, things broke. That's a likely suspect. The same kind of applies to PRs. If I ship you a monster multi-thousand line PR, it's going to take a lot of time to dig through that. If I do that bit by bit and say, okay, what are the logical components that you can break this up into, that's not just easier to write, it's also cognitively easier to read. It's much easier for me to say, okay, I only have a little bit of context I need to keep in my head before I go on to the next PR or the next bit of code that I write. And so we try to keep our changes relatively small.
Awesome, thank you. Next question's from Kim. If you have multiple production environments with different features turned on and off, do you manage separate replicated data stores for each production environment?
We do, yes. So we have separate data stores for each of these environments. That is made much cheaper as far as engineering time is concerned by the fact that our environments are all in code, right? So we don't develop a separate production and dog food and kibble. We say, here is my environment. I have one with production config and one with dog food config and so on. We do also have the opportunity to deploy smaller canaries. So yeah, I can deploy a single node PR of a service or two into dog food and share the data stores that the dog food environment uses. But for the most part, our large environments are all separate sets of data.
As a side question, how long does it take you to be able to talk about the dog food and the kibble environments without laughing?
I thought they always made sense.
They do make sense. Sorry, that's a non-legit question.
I feel like that's a running joke. Which dog joke are we going to make this week?
Scooby snacks. All right, back to the serious proper questions. This one's from Anonymous. How do you implement/manage feature toggles if they're used with every feature? Do you remove them after deployment?
Oh, yes.
No.
No?
We don't use them for every feature, right? There are absolutely things go out that don't need a feature flag. If I'm fixing a typo, it doesn't need a feature flag, I want that. If I'm changing the color, I may or may not want a feature flag. If I'm adding an important widget to our UI, yeah, that probably wants a feature flag. So the first step is, okay, feature flag goes out, we can leave it on. We do eventually want to clean that up, but it's kind of harmless. It's not a rush. The second step is, what's our tooling? Am I confident when I push my code to production that the feature flags I've defined in code are the same as the feature flags defined in Launch Darkly in our feature flag service? So I don't want to deploy code that depends on a feature flag that we took down. So we check for that. So it's very much, do I have the right tooling in place to manage my feature flags? But it doesn't have to be, oh yes, everything comes in and comes out on a per deploy basis, because maybe this is a feature that I'm rolling out gradually, I'm iterating on it internally, and much later down the road, it'll be rolled out to more customers.
Okay. The next question is from Ansel. How do you set up a dog food environment? How easy is it? What are the high-level steps involved? And when does it make sense to not have a dog food environment? That's like 4 questions in one. That's cheating, Ansel. Did you get all those? How do you set it up? What are the high-level steps involved? And when does it make sense to not have one?
I'm gonna draw on his giant here and say it basically never makes sense not to have something. But if we go back to this idea that all of my infrastructure is automated, all of my infrastructure is in code somewhere, that makes it much cheaper to say, oh yeah, I'm gonna do a second copy of that same first thing. I'm just gonna put a couple different feature flags on it, a couple different config values in it. So it's the same code, but oh yeah, it's pointing to a different database. It's the same code, but I've got a different DNS record that points at it. It's the same code, but instead of running 100 instances, I'll run 4 or 5 because I'm not using that much load. And it turns out it's much easier to do that from day one when your system is small than it is to go, oh wow, I have this massively complex service and now I need to replicate all of it. So you might end up in that boat. It's possible to walk back from that, but it's much better to say, no, it's worth investing in this today, even though we're a very tiny organization, because by the time we grow enough to want it, it will be much harder to build it.
Yeah, good advice. The next question is from Patrick. Do we know how much performance hit does ingesting telemetry have on the product?
Ooh, I know this is something we've looked at. I don't have a specific answer. Do you, Jess?
Is it ingesting that's a concern or emitting?
I feel like this is a question about emitting. What's it going to cost me to put this stuff in my code?
Right. And it's, I mean, how much does logging cost you? It's kind of similar.
And what's the value trade-off? Right? I get value from knowing that, from having access to this data. Is that worth the performance hit? I will say, as a broader answer to this, we have a team dedicated to telemetry that's dedicated to questions like, what does it look like to instrument an app? What are the trade-offs? What are the costs for both developer time and also performance? Unfortunately, neither of us are on that team, and I would encourage you to come to ask in Slack, but generally it's worth it, and it's a thing that we've optimized for when building these tools.
Yeah, and by Slack, Ian, do you mean the Honeycomb pollinators Slack?
Thank you. Yes. Yeah,
there's a public Slack. Oh, I should have the link for that, where everybody discusses Honeycomb. And that's a great place for any question like that, because our experts will jump in.
Maybe we can get that from you after this and add it into the chat so that people can find it and go and join. Awesome. Okay, the next question, and I'm sorry, I'm going to probably mess up pronouncing your name, but I'm going to have a go. Baya Lakshmi wants to know, as a team, you want to improve your CI/CD processes. Does it make sense for the same team to be on production support as well, based on you develop it, you maintain it, but how to do both? Any thoughts?
So we very much believe that everybody is on call. We believe very much as a company that developers interacting with production is good for development, that looking at what's going on in production is a necessary component of writing reliable code. So yes, on some level, everybody is directly interacting with production. There's nothing really stopping you from interacting with that component of our system. At the same time, yes, we also see value in specialization. So we mentioned right now that we're making a shift over to Kubernetes. Right now, that's a team of 3 engineers in our company. And the goal here is not that the 3 of us are going to run this new infrastructure forever, but we're there to explore what's out there, figure out how Honeycomb is going to use this new tooling, develop processes, develop documentation, and then bring it back to the rest of engineering and say, hi, here's what we built. Let us sort of teach you the new way that Honeycomb is doing things. And so at the end of the day, there's a little bit of both, but we do believe that if you develop it, you are going to have to maintain it. that's just how the world is.
Fair enough. And last question from Sam. What process/guidelines do you have around creating observability, e.g. metrics for changes? So when is a metric required and when can it be skipped? And can a PR be rejected if metrics are missing?
Okay, can I talk about what's metrics and what's observability?
You can, but there's an interesting question here around the review flow. Shall we take both?
Yeah, you go first.
Sure. So we did not have anything terribly formal around this until I want to say December of last year, January of this year. And we still don't have anything super heavyweight. What we have right now is a template, a PR template in GitHub that, you know, it already had a thing saying, here's a summary header, here's a link to the ticket that this work is for, you know, here's your explanation of test plans, go fill it out as you see fit. We added a new header to that and said, what are you going to observe to see if this worked? And we believe in empowering developers and trusting developers. So it's not that every PR has that happen, but it's an entirely legitimate thing for a reviewer to look at your code and say, okay, this looks nice. How are you going to know if it worked? How are you going to know if it totally tanked performance? Like, what's the thing that you're going to look at next? And that might look like, oh yes, I added a new bit of instrumentation. There's a new signal that's coming out from the code that will tell me. It might be, oh, we already have something that covers this case. Here's the query for what that looks like. Here's the board or the graph that I'm going to look at, and I expect to see, you know, my CPU wiggling up here suddenly drops down a little bit. True story. We did a deploy like that in January. I expect CPU to drop down by about 15-20%, and oh hey, here's that. So it's the sort of twofold answer here is, one, we encourage it and we endorse it and we say, what are you looking for here? But we don't require it, because it's absolutely true that not every single change needs to have that level of attention. Not every change needs to have an explicitly added new thing just to check that box. That's not valuable. Jess, do you want to talk about metrics versus observability?
Yeah, so while you're talking about like adding a new thing for not every change, but I mean, every code change that you do want to be able to observe in production, like maybe you add a new database query and you want to be able to say how much that affected performance, whether it's running, is it behaving as expected? Watch out for metrics, because if you're using a normal metrics tool, every metric you create costs something. It costs like an entire time series and can be expensive. And it just gives you one number. One reason we can do this at Honeycomb is because we're making all these graphs based on events, and adding another event. Well, it's like adding another log statement. It's very small impact. It does not create an entire time series. And we're making a zillion different graphs off of the same set of events. So being able to make a new graph is not expensive. Maybe it's just adding another attribute to an existing event, lets you know whether or not they're using your new feature. So there's a big difference between observability and metrics. I'll let you Google that if you want to, or check our blog. There's good stuff on there.
Ask on Twitter, you'll get a great fight going. So actually, I'll add a true story here, and we've done this a couple times in my time at Honeycomb. You launch a new feature or a new component to the system, and I'm thinking here in particular of earlier this year we started taking gRPC ingest. So we've always supported sending us your data over HTTP. Now we also support gRPC. Cool. And the team that worked on that put that together and shipped it, and then said, okay, but we want to know who's using this, right? How many customers do we have using this? How much of their data are they sending our way? Like, is this just a little test stream, or is this everything? Like, what's going on there? And so they can find that out by looking at, oh, right, it goes to a slightly different port. It's got a couple of different fields on that data that we can filter by. We can say, oh, here are the 2 customers that sent us gRPC data the day it launched. At our company conference just a couple months ago, we added a metrics feature, and we were able to say, oh, here are the customers that were so excited for that. They started trying it out right as soon as we announced it. That's kind of cool. And then we can follow up on that and say, oh, a month later, here's the additional larger group of customers that are using this. And here are the ones that have fully bought into it. And here are the ones that they've tried it out, but they're still using the old legacy thing. And so you have the ability to say, not just, what's this doing to the CPU load of my overall system? You can say exactly who is using it, when are they using it, how much are they using it, and also what's that doing to my performance.
Yeah. Whereas if you're using a traditional metric system, please do not create a metric per customer ID. You will regret that. But with events, it works smoothly.
Fantastic. And we are out of time for Q&A. That was great.